Hi everybody, hi, welcome to Momentum with Vedantu guys, welcome to Momentum with Vedantu. Hi Akash Dev, hi Divyansh Agarwal. Divyansh Agarwal wants advanced questions on kinematics. Alright Divyansh, we will most probably do that. We will most probably do that. First of all, good afternoon everybody. Welcome to Momentum with Vedantu. I am Aaditya Pandya. I am going to be your master teacher for physics, and today we are going to solve 5 advanced level questions on current electricity. Now, guys, current electricity is one of the easiest chapter out there. Okay, it's there's not much there which can confuse you. There is not much there which you can't get your head around. So it's an easy chapter, but also at the same time, it has high weightage. Every year they at least ask one question from this. Sometimes they ask two questions from it. So it's an important chapter. Okay. So it's good that we do advanced questions from it. Okay. Hi Sunny Babu. Hi Akash Dev. Hi everybody. Hi. Welcome. Okay. Hmm. So, by the way, guys, so let's start with today's session. Okay, let's start with today's session. We are going to talk about current electricity. Okay, liquid nitrogen, my friend, most probably know. Okay, all right, guys. So, oh, hi, Ghanshyam. Love from my home as well. Okay, love from Vadodara as well. Okay. All right. So, Ari, it's okay, Usha. It's okay. Okay, Ghanshyam, mathematics exactly. Advanced questions. Now, these are the easier one of advanced questions. I will do more hard advanced questions as well later if you find these two easy. These are actually advanced level questions, but the easier one of those. Okay, if you want me to do the hard level ones as well, you tell me. Okay, the thing is, guys, even in a JEE Advanced paper, there are going to be some questions which are easier than others. Okay, so we will try to do those first. Okay, first of all, if you haven't joined our Momentum with Vedantu Telegram group, guys, I suggest you do that. We post notes there every day. Okay, new stuff. We will keep posting on it every day, including the notes, including assignments, and whatever else you demand. Okay, so starting with current electricity. Starting with current electricity. Yes, can I? Do I need to speak louder? Okay, I will speak louder, guys. I will speak louder. Okay, I will speak a little bit louder. I will speak a little bit louder. I think there needs to be some adjustment with my screen here. Something is not right here. Something is not right. Okay, let me try to adjust it a little bit. Yeah, something was not right. I was feeling something was not right. Okay, it's adjusted now. Yeah, sometimes you have to do it, guys. Sometimes you just have to adjust your screens right in middle of the class. Okay, shh, don't tell anyone. Okay, all right. So let's start with the first question. Okay, let's start with the first question. First question. Yeah, Ghanshyam, attempting 50% is more than okay. That will get you through IIT if you do that, but do all of them correctly. Okay, 50% marks is like super good score. Okay, you get into top at least top 5,000, at least top 2,000. Okay, so yeah, definitely. Okay, all right. So guys, let's look at the first question and let's try to solve it. Okay, so I have a galvanometer here which is first converted to a voltmeter by connecting this resistance, and then it is connected to an ammeter by connecting this resistance. Okay, now in case of galvanometer, guys, or in case of galvanometer getting turned into ammeter and voltmeter, you always need to remember the diagrams. Always need to remember the diagrams. Whenever a galvanometer is converted to voltmeter, whenever a galvanometer is converted to voltmeter, remember this diagram. This would be the galvanometer, okay, connected in series with a resistor. Now this resistor can sometimes be called R, this sometimes can be called S, whatever. Okay, and in this case the current through the galvanometer is always equal to Ig, the maximum deflection current, and the potential difference between these two terminals will be plus and minus V, plus and minus V. Okay, what do I mean by this, guys? So if you look at this question, the current is given as 0.006 amperes. This is the galvanometer full scale deflection current Ig. Okay, the resistance is 4,990 ohms. Okay, so what we are given here is that this resistance is 4,990 ohms. This is equal to 0.006, 0.006. And potential difference. What is the potential difference here? 30 volts. Okay, the 30 volts. Yeah, अरे किसी का तो आंसर आ गया था 30 volts. Okay, somebody has already solved this question before. Akash Dev, oh ho ho, oh ho ho. Okay, now if you see in this case, let's say the resistance of the galvanometer is Rg. Okay, what I can say is a very simple equation that I can say is that V is equal to Ig into Rg plus R. The potential difference will be equal to I into R. In this case, these two are in series, so total resistance will be Rg plus R. Just substitute all the values here, guys. You will get 30 is equal to 0.006, 0.006 into Rg plus 4990. Okay, now if you see Rg plus 4990 from this will be equal to 30 divided by 0.006. Okay, when you solve this 30 divided by 0.006, that comes out somewhere around, I feel it will be, if I'm not wrong, yeah, it will be 5,000. It will be 5,000. Okay, you have to remember when you cancel, you have to remember when you cancel, you know what, let me cancel. Okay, so 6 ones are 6 and 6 fives are 30. Okay, that will become 5,000. This gives me Rg is equal to 10 ohms. Okay, now that I know the value of Rg, now that I know the value of Rg, I can calculate the value of the second part of the equation, the second part of the question. I have to calculate this N. Okay, now, Dr. Mohammed is asking how, sir? Are Dr. Mohammed, V is equal to IR. Now, my friend, the potential difference V will be equal to the current into the total resistance. Potential difference V is equal to current into the total resistance. Now, guys, in the second case, what is happening is I'm converting it into an ammeter. So, here also, once again, you need to know the circuit. What is the circuit? The circuit is going to be like this, a resistance in parallel to the galvanometer. Now here I already know the resistance of the galvanometer is 10 ohms. Okay, and I know that the current through the galvanometer is going to be Ig, which is 0.006 amperes. Okay, and also at the same time, which is equal to 0.006, यार हो जा 0.006 amperes. Okay, and also at the same time, when I connect this shunt resistance, the maximum current that comes through here is 1.5 amperes as per given in the question. Okay, now once again, guys, how do I solve this question? So you have to remember that the current here in this case will be equal to, the current here in this case will be 1.5 minus Ig. 1.5 minus Ig. And what you can say is that the potential difference across this galvanometer will be same as the potential difference across this shunt resistance, or basically I1 R1 will be equal to I2 R2. Okay, so what is I1 here? 0.006 into resistance is 10. That should be equal to 1.5 minus 0.006 into the shunt resistance, which is 2N divided by 249. 2N divided by 249. Okay, now here, guys, it might be useful to us, to just you know what, I am going to remove a few things. Okay, it might be useful to us to just approximate 1.5 minus 0.006, approximate it to just 1.5. I get 0.006 into 10 divided by 1.5 is equal to 2n divided by 249. Okay, now once again, we just like we approximated this as this, also let's approximate 249 approximately as 250. Okay, so let's just write it like that. In the exam, sometimes you can do approximations, you do calculations become very, very easy. Okay, now when you do that, guys, see everything becomes super, super simple. You have to remember 15 into 0.1 is 15. 15 into 0.004 is 0.006. Okay, which gives me 2n. Russell is asking, sir, can we expect two lectures for NEET and JEE daily? No. Yes, Kaushik, I will share the notes after the class. Okay, do not worry. Okay, which gives me 2n is equal to 10 into 0.004 into 250 divided by 0.1. Okay, now guys, 250 into this 2n, this will give me as, oh my god, oh my god, oh my god. This will give me 250 into 0.004. What is 250 into 0.004? Oh, ho, ho, 250 into 0.004. I know my answer, but I am still confused. So it will be 1 only. So this will be 10 into 1 divided by 0.1. This gives me very simply, this gives me very simply, oh, I made a mistake here, I made a mistake here. Oh, this will not be 0.1, this will just be 1. Sorry guys, I made a small calculation error here. Okay, I made a small calculation error here. This will just be 1. Okay, so this will just be 1 and 1, which gives me the value of n as equal to 5. Akash Dev was correct. Akash Dev was correct. Okay, basically guys, you don't look at my calculation, look at the procedure. Once you have this equation, you can easily calculate the value of n. Once you have this equation, you can easily calculate the value of n. I hope everybody understood. Okay, I did make a calculation error, but you know what, I was just seeing if you guys were paying attention, and you passed the test. You were paying attention. Okay, all of you were paying attention. Definitely you were. Definitely you were. Okay. Anyway, so let's move on to the next question. Okay, let's move on to the next question. I think it's time for us to move on to the next question. Okay. All right. Yeah. I hope everybody understood. Okay, I really hope everybody understood. Now, this is the next question, guys. Resistance of 2 ohm is connected. These advanced level questions. These just so big questions. My God, so much to read here. I get bored while reading, but okay, so let's try to read this. Okay, so a resistance of 2 ohm is connected across one gap of the meter bridge, and an unknown resistance which is bigger than 2 ohm is connected across the other gap. Okay, when these two resistances are interchanged, then the balance point shifts by 20 centimeter. Then the balance point shifts by 20 centimeter. Okay, neglecting any corrections, find the unknown resistance. Okay, neglecting any corrections, find the unknown resistance. Okay, so how do we solve this? Kavya, yeah. I understand your problem, my friend. I understand your problem. We are coming up with that. Okay, don't worry. Okay. Okay, in the meantime, guys, in the meantime, what do we do here? What do we do here? Okay, how to solve this? So first of all, let's just make diagrams. Okay, I love making diagrams, especially for questions where visualization is not very easy. Okay, so let's say this is a diagram of a meter bridge. Okay, I have a battery here, something like this, and a meter bridge wire here, something like this, and a galvanometer is here with some with a certain uh, balancing it. Okay, so this is, let's say, the situation. We are given the two unknown resistance, two known and the unknown resistances. This is 2 and this is unknown. Let's call it X. Okay, this is the case 1. Here, let's say this length is equal to L1. Let's say this length is equal to L1. So the other length will be equal to 100 minus L1. And since I know that the other resistance X is bigger than 2 ohms, since I know that X is bigger than 2 ohms, therefore I know that L1 will be less than 50 centimeters. Okay, L1 will be less than 50 centimeter. Since this resistance is bigger, therefore this length will also be bigger. Okay, if the resistance is bigger, the length will also be bigger. So the L1 will be the smaller of the two lengths. Okay, I hope everybody understood. Okay, Sam Niran, yes, JEE mains questions are supposed to are going to be easier than this. These are advanced level questions. Okay, now what happens is, guys, what happens is that they are exchanging the two resistors. Okay, what are they doing exactly? What are they doing? Let me explain what they are doing. So I made the other diagram once again. This time what happens is that they exchange the two resistances. Okay, so now X will be here and 2 will be here. X will be here and 2 will be here. I hope everybody understood. Now, in this case, the balancing length is also going to change to some other value. The balancing length is also going to change to some other value. But here is the fun part. Okay, here is the fun part. What happens is that if this length was L1, then my friends, this length will be L1 now. This length will be L1. Okay, if this length is L1, then this length will be advanced. No, Akash Dev, because advanced is coming now, so we are working towards advanced right now. We are working towards advanced right now. Okay, we have, because advanced test is coming. So because this length is because 2 is interchanged, the lengths will also interchange. Now here is the thing, guys. Here is the thing. What they have said is first, once again, this will be 100 minus L1. I hope everybody can see. Now, what they have said is, it's very important what they have said, that the balance point shifts by 20 centimeter. The balance point shifts by 20 centimeter. What this means is that between these two points, the distance is 20 centimeter. Between these 2 points, the distance is 20 centimeter. Okay, because, oh, okay. Dr. Mohammed is asking, sir, how is x greater than 2? Because it's written in the question, Dr. Mohammed. Because it's written in the question. Okay, it's written in the question. Okay, so guys, using this, I can write a very simple equation that will solve all of my problems. Okay, I can just write L1 plus 20 L1 plus 20 will be nothing but 100 minus L1. L1 plus 20 will be nothing but 100 minus L1. Okay, from this you can get 2L1 is equal to 100 minus 20, or L1 is equal to 40 centimeters. Okay, so guys, this length is 40 centimeters. So can I ask you how much will this length be? Can I ask you how much will this length be? It will be 60 centimeter. Okay, so now that I know both the lengths, I can easily calculate the value of x. I can easily calculate the value of x. Okay, how will I calculate the value of x? How will I calculate the value of x? I can write 2 divided by 40 is equal to x divided by 60, which gives me x is equal to 60 by 40 into 2, which is 3 ohms. Just 3 ohms. Yes, correct. Akash Davis, correct. Very good, very good, very good. Durga, very good, very good. Okay, so this was the answer to the second question. Now, guys, before we go forward, very quick announcement. First of all, if you haven't joined our Telegram group, guys, please join our Telegram group. I daily share the notes on this group, and also at the same time, we share other assignments and everything for you guys there. Okay. Also, at the same time, if you are a JEE and NEET 2020 JEE 2020 students and are preparing for JEE Advanced, we have a special offer for you. Okay, Vedantu is starting the JEE Advanced course. Vedantu is starting with the JEE Advanced crash course. Okay, and it was supposed to be 29,999 rupees for the crash course, but for you guys, it's made very cheaper. It's just 1,999 for the entire crash course. Okay, all three subjects: physics, chemistry, maths. Okay, and you can get that crash course by going on to this link vdnt.in/JEE crash course E. Okay, JEECCE. Okay, and when you go there, use my coupon code AAPCC to get this special discount. Okay, anyways, moving on. Sam Niran, I will start soon. Don't worry, I will start soon. Moving on, let's get to the next question. Now, this next question, guys, is a mixture of current electricity, and it's a mixture of current electricity and a capacitance. Okay, and it's a khatanak question. It's a khatanak question. Okay, but let's try to understand what exactly is happening. Okay, so what is happening here is, guys, a circuit is connected like this, and the switch S is open. Now, after the switch S is closed, find out the charge that flows from Y to X. After the switch S is closed, find out the charge that flows from Y to X. Now, in order to solve this question, guys, you need to have a good working practical knowledge of, current electricity and capacitors both. Okay, so how do we solve this, guys? How do we solve this? Okay, so in order to solve this, let's look at this circuit one by one. In the first case, let's keep S as open. Okay, in the first case, let's keep S as open. Okay, so now if S is open, guys, what will happen here is I can write down potentials at various point on this circuit. Okay, let me take this as the reference as zero potential. If this will be zero potential, then this will also be zero potential, this will also be zero potential, this will also be zero potential, and this will also be zero potential. And if I jump across this battery, then that means this will be 9 volts potential, this will be 9 volts potential, this will be 9 volts potential, and this will be 9 volts potential. I hope everybody understood how I'm writing the potentials. Okay, I hope everybody understood how I'm writing the potentials. Now, in this case, guys, what will happen is that there will be some current through here. Okay, and there will be certain charge plus q and minus q here, because these are capacitors, they will have charges, and also the same charge plus q and minus q here. Okay, you have to understand that there will be no flow of charge through this branch, because what will happen in this case, because that switch is open, so there will be no flow of charge. Okay, and in this case, I can just consider these two capacitors in series. In this case, I can just consider these two capacitors in series. Okay, and if I ask you what will be their equivalent capacitance, so you can very easily calculate their equivalent capacitance. You can say 1 by C equivalent is 1 by C1 plus 1 by C2, or 1 by C equivalent is equal to 1 by 3 plus 1 by 6, which gives me C equivalent is equal to 2 microfarads. Okay, and if I want to calculate the value of this charge Q, guys, if I want to calculate the value of this charge Q, I can write Q is equal to C equivalent into V. Now C equivalent is the 2 microfarads. What is V? V is the potential difference across this series. Can you tell me what is the potential difference across this series? Can you tell me? Can you tell me? Can you tell me? The potential difference across this series is nothing but 9 minus 0. Higher potential minus lower potential. Hi, Leander. Okay. So from this, guys, you can write Q as equal to 2 into 9, which is 18 microcoulombs. 2 into 9, which is 18 microcoulombs. I hope everybody understood. Leander, I am good. How are you, my friend? I hope everybody understood. I really hope everybody understood, guys. Okay. Okay, now let's talk about the next case. The next case is when the switch S is closed. Okay, the next case is when the switch S is closed. So, so let's write switch S is closed. Okay, now weird things will happen. Okay, so but pay very close attention. Pay very close attention. So now what will happen, guys, is that since the switch S is closed, these 2 points will have the same potential. Okay, so the potential at this point will also be equal to Y. The potential at this point will also be equal to Y because now they are connected at the with the same with a connecting wire. So now, if this point I consider as zero potential, this will also be zero potential, this will be zero and this will be zero. And if this point will be 9 volts, then this will also be 9 and this will also be 9. Okay, now what happens is now these two are no longer in series. Now these two are no longer in series. So now they will have different charges. Okay, let's say the first one has charges plus and minus Q1 and the second one has charges plus and minus Q2. Okay, and I want to find out these two charges, but in order to find them, I need to do some calculations first. In this case, let us try to calculate this current I. Okay, now guys, if I want to calculate this current I, what can I write? I have V is equal to IR. Here V is supposed to be equal to potential difference. So if I write this equation for the 3 ohm resistor, I can write 9 minus Y is equal to I into 3. Because across this 3 ohm resistance, the potential difference is 9 minus 1. Okay, similarly, I can also write y minus 0 is equal to I into 6. Y minus 0 is equal to I into 6 because across this resistor, the current is still I and the potential difference is Y minus 0. Potential difference is Y minus 0. Now, if you divide these two equations, guys, if you divide these two equations 1 and 2, okay, I will just write 1 divided by 2. What will I get? I will get something like 9 minus y upon y minus 0 is equal to 3 by 6. Okay, and 3 by 6 everybody knows is 1 by 2. So I get 2 into 9 minus y is equal to 2 into 9 minus y is equal to y, or 18 is equal to 3y, or y is equal to 6 volts. Okay, a lot of calculation. I hope everybody is following. I hope everybody is following. Okay, now if y is equal to 6, guys, then my calculation becomes a little bit easier. Okay, if y is equal to 6, then I know potential at all the points. This point was 0 potential, this point was 9 volts, and 6, since y was equal to 6, that means this point is also 6 volts potential. Okay, now I can calculate both the charges very easily. Let's say this is plus and minus Q1, this is plus and minus Q2. What will be plus and minus, what will be Q1? Q1 will be equal to C1 into V. So that will be equal to 3 into 9 minus 6, that is equal to 9 microcoulombs. 3 into 9 minus 6, which is equal to 9 microcoulombs. I hope everybody understood. And Q2 will be equal to what? Q2 will be equal to C2 into V. That will be equal to 6 into 6 minus 0. The potential difference is 6 minus 0. That is 36 microcoulombs. So Q2 is 36 microcoulombs. Q2 is 36 microcoulombs. I hope everybody is following so far, guys. I hope everybody is following. Now my job gets a little bit tougher. Okay, now my job gets a little bit tougher. So let's try to understand what exactly happens here. Okay, now my job gets a little bit tougher. So let's try to understand how to solve this. Okay, guys. So let's write the initial and final charges here. Okay, initially the charge here and here, both the places, was how much? I got the initial charges as 18 microcoulombs. So here I had plus 18 microcoulomb, here I had minus 18 microcoulomb. And initially here I had plus 18 microcoulomb, here I had minus 18 microcoulombs. Okay, and finally if you write the charges, guys, finally if you write the charges, finally the charges are a little bit different. Finally the charge here is plus 9 microcoulombs, and here the charge is minus 9 microcoulombs, and the charge here is plus 36 microcoulombs, and the charge here is minus 36 microcoulombs. Okay, I hope everybody can see the plus and the minus charges. So initial charges, the final charges. Initial charges, the final charges. Okay, let me write the initial charges more beautifully. These are ugly. Okay, let me write it my plus and minus 18. Okay, better to write it properly. Minus 18 and plus 18. Okay, now if you look at the initial and the final charges, guys, if you see there is some extra charge flowing from here. Okay, what will happen is when I close this switch, some charge Q will flow from here to here, and that will change the charge from minus 18 plus 18. If you just look at this region, which region am I telling you to look at? If you just look at this region. Okay, 1 second. Okay, if you look at just this region, inside the charges are minus 18 and plus 18. What happens is that changes into minus 9 and 36. So how does that happen? How does that happen? Some charge must have flowed into that region. Okay, so what I can write is that this charge minus 18 plus 18, when you add an extra q onto it, that will give you the final charge, which is minus 9 plus 36, which is minus 9 plus 36. Okay, and if you solve this, guys, you will get the correct answer. If you solve this, you will get the correct answer. You will write minus 18. You will write minus 18 plus 18 plus q is equal to minus 9 plus 36. Okay, which gives me q is equal to 36 minus 9, which is 27 microcoulombs. This is how much charge will flow from here to here. This is how much charge will flow from here to here. I hope everybody understands. Okay. Initial charges, final charges, initial charges, final charges. So after initial charges, some charge will flow and it will make the final charge. Okay. Some charge will flow and it will make the final charge. Some charge will flow and it will make the final charge. Okay. And we will have to use the law of conservation of charge to get the correct answer. I hope everybody followed. I hope everybody understood, guys. I really hope everybody understood. Okay, now the next question is an advanced level question, but it's an easy question. It's a very easy question. I think you guys can understand this, solve this question very simply. Okay, I have two resistors. I have two different conductors, one from A to B, the other one from B to C. Okay, and you have to find which of the following statement is correct. Now, guys, here what I will do is first I will calculate the resistances of both the case. Okay, first I will calculate the resistance in both the case. Okay, first of all, let me make this picture a little bit smaller because it's not of my use. Yeah, let's make it smaller. Okay, so first let's try to calculate the resistances. If I ask you what will be the resistance from A to B, so it will be equal to rho L by A, which can be written as resistivity into L by 2 divided by pi into 2R the whole square. If you calculate this, this will be rho L by 8 pi r square. Rho L by 8 pi r square. I hope everybody can see this. Similarly, if you calculate the resistance from B to C, if you calculate the resistance from B to C, what you will get is that will once again be rho L by A, that will be equal to rho into L by 2 upon pi r square. That will be rho L by 2 pi r square. Now guys, let's call this resistance as equal to R. Okay, some value R. Let's call this entire thing as R. Then this will become equal to 4R. Can you see that? This will become equal to 4R. I hope everybody can see this. I hope everybody can see this. Okay. If one of them is considered as R, the other one can be written as 4R. Now, why does this help us? Why does this help us? Because now we can compare everything. Okay. You just have to remember that resistance from A to B is equal to R, the resistance from B to C is equal to 4R. You see, radius reduces to half, area reduces to 1/4, and therefore resistance becomes 4 times. Now, if the current here is I, the current here will also be I. Okay, if I calculate power in the part A to B, if I calculate power in the part A to B, what will be power in the part A to B? Power in the part A to B will be I square into R. Power in the part B to C is equal to I square into 4R, which gives me power in the part BC, which gives me power in the part BC as 4 times the power in the part AB. Similarly, if I compare other things, if I calculate voltage in the part AB, that will be equal to I into R. Okay, 1 square. Yeah. And if I calculate voltage in the part BC, that will be equal to I into 4R, which gives me voltage in the part BC as 4 times voltage in the part AB. Okay, if I calculate current density, the current density in the part AB will be equal to I divided by pi into 2R the whole square. Okay, and current density in the part BC will be equal to I divided by pi into pi r square. Sorry, pi into R square, which if you compare once again gives me current density in part BC is equal to 4 times the current density in the part AB. Okay, what else? What else? What else have they have told us to compare? We are going to talk about voltage, we are going to talk about power, current density, and then finally electric field. Okay, let's talk about electric field as well. Let's talk about electric field as well. How do you calculate electric field in the part AB and BC? Very, very simple. Very, very simple. Okay, electric field in the part AB is equal to the potential difference divided by length. Electric field in the part AB will be equal to the potential difference divided by length. Similarly, electric field in the part BC will be equal to the potential difference divided by the length. Now, since the potential difference in the part BC is 4 times potential difference in the part AB, therefore the electric field in the part BC will also be 4 times the electric field in the part AB. Now remember these 4 equations because this is what we will have to compare. Electric field, current density, then potential difference. Okay, oh my god. Then potential difference, and then power. Okay, so comparing all of this, if we go back to our original question, if you go back to our original question, if you see this statement is wrong, it's not two times, it's not two times. This statement is correct, this statement is wrong, and this statement is wrong. Their electric field and current densities are not equal. Okay, so the only correct answer is option B. Hi Vedika. Hi Hina Hanan. I hope everybody understood. I hope everybody understood. Guys, if you did, please give me a thumbs up. Okay. The thing is, you just have to know the correct formulas which one to apply. Hmm. Ha. Now, next is, guys, next is, if you understood so far, let's talk about the next question. The next question, I think there's a mistake in this question, but you know what? We are going to ignore this mistake and just try to solve this. Okay, so this is the question. I have to calculate the resistance. See, everything is given in the figure only. I have to calculate the resistance with the errors. Okay, I have to calculate the resistance with the errors. Okay, so how do we do this, guys? How do we do this? How do we do this? Okay, so in order to understand this, let's do something very, very simple. What we do is, first of all, let's just keep our diagram in view and let's remove everything else. Okay, I don't want to look at the question or anything. I just need the diagram, guys. Love the diagram. Diagrams makes things clear. Okay, now if you look at this diagram, guys, if you look at this diagram, what will you see? If you look at this diagram, what you will see is that this distance will be equal to 60.0 centimeters. Okay, 60.0 centimeters. So I can write R divided by 40 is equal to 90 divided by 60, which gives me R is equal to 40 into 90 divided by 60. That will be equal to, my maths is weak. How much will this be? This will be 64. Okay, but we are not interested in the exact value of resistances. Okay, if you see, there are two options which give this as the correct answer, but both of them have the different error value. Both of them have the different error value. Okay, so this is where we have to understand how to solve it further. Okay, now in order to understand that, look at this. What is given to us is that the least count of the meter bridge is 1 mm. Okay, or you can write this as 0.1 centimeter. Okay, I hope everybody understood. I really hope everybody understood. Nothing so far. Now, here, if I just write down the formulas, okay, let's just for a minute, let's just talk of them as L1 and L2. Let's just call them as L1 and L2. Okay, and write down the formula. I will get the formula R divided by L1 is equal to 90 divided by L2, which gives me R is equal to 90 L1 by L2. Now, if I am going to do the error analysis, guys, I can write delta R by R is equal to delta L1 by L1 plus delta L2 by L2. Okay, now this is where you just have to substitute all the correct values. You are given already most of the values. You already know most of the values. First of all, the value of R, we have just calculated, it is 60 ohm. Okay, we are given the value of L1 as 40, the value of L2 as 60. Okay, and the value of delta L1 and delta L2 both will be equal to 0.1 centimeter because the least count is 0.1 centimeter in both the cases. Okay, so let's just substitute all these values into the equation. I will get delta R by 60 is equal to, one second, yeah, delta R divided by 60 is equal to 0.1 divided by 40 plus 0.1 divided by 60. If you solve this equation, your delta R will go to 60 into 0.1 by 40 plus 0.1 by 60. Okay, that will give you 1.0.15 plus 0.1, that is 0.25 ohm. So if your error in the resistance is 0.25 ohms, you can now easily tick the correct answer, which will be option C, which will be option C as the correct answer. Your resistance comes out as 60 and the error in the resistance comes out as 0.25. Okay, so that will be option C. I hope everybody understood. I hope everybody understood. Okay, now Jojo is asking, sir, can't we do just by applying formula of meter bridge? Jojo, I have done it again. Once I have to apply this formula, R by 40 is equal to 90 by 60 to calculate R. To calculate R. Okay, this I am doing to calculate R. But then I also have to calculate delta R. उसके लिए I will have to use the formula delta R by R is equal to delta L1 by L1 plus delta L2 by L2. Okay, that's why I'm using it twice to calculate delta R. To calculate delta R. Okay, that is how we solve this question. First we calculate R, then we calculate error in R. Okay, that's it, guys. This was the fifth question. That is it for today. I will end this session here. But before I go, let me give you a homework question. Okay, now this is also an advanced level question, but I am sure you can solve this. I am sure you can solve this. Okay, so try to solve this question, guys. Try to solve this question. It's a very simple. It's not a simple question, but it's an advanced level question. But I think you guys can do it. Okay, I think you guys can do it. Solve it and write answer in comments. Write answer in comments. Alright guys, and this is where I will stop my class today. I love doing advanced level questions. If you have Hina Hanan wants a Menti class. Yeah, Hina Hanan, I have not done Menti class in a long time. Probably we will have a Menti class this Sunday. Okay, probably we'll have a Menti class this Sunday. Don't worry. Okay, what is the topic in which on which you want Menti class, Hina Hanan? Can you tell me what topic you want me to do Menti class on? What topic? What topic? What topic? Okay, we will do a Menti session. We will do a Menti session on uh, the class 11 topic. Okay, that we are doing the KTG and all that topic. Okay, modern physics. All right, you know what, guys? You know what? What I will do is either write down whatever you want Menti session on in the comments, or message me the topic you want to take Menti session on Telegram at AADITYAP832. Okay, message me the topic you want the Menti quiz on this address. Okay, so we will do that. Yeah, I think I should take a Menti quiz on thermal properties and KTG only because that is the thing I have been teaching. Okay, so let's do that. Let's do that. Okay, that's it for today, guys. That is it for today. That is it for today's class. It was such a fun time teaching you. I love you guys. Okay, and I will see you again tomorrow. Okay, I will see you again tomorrow. Have a nice day, everybody, and bye bye. Bye bye. Bye.